Hi, hope everybody's well. So this video is going to introduce us to dimensional analysis. So you guys have seen this somewhat before. Dimensional analysis really, it's just conversions. And it's really a lot of what we will be doing for the rest of the year. But as I mentioned this week, if you have and use and follow your units, you can use that to help you solve the problems and make you sure that you're setting them up correctly. So dimensional analysis is a way to do that. So for dimensional analysis, we will be using train tracks again to help us set it up and just keep us organized. And you will be using this, especially if you go into physics with Mr. Schwabe. So it will be a good skill to learn. All right, so with units or in algebra, right, say that we have like x over x. Well, we can cancel those out and they equal 1, right? So you can do the same thing with units, and it does not matter what the unit is. If you have grams over grams, you can cancel that out, and it will equal to 1. Let's say that we're doing density, which we just talked about. If we have grams per centimeter cubed over grams per centimeter cubed, you can even cancel those out, and it will equal 1. All right, so if we can keep track of this and make sure that our units cancel to where we get the final answer that we want, the final unit that we want, it helps us make sure that we're setting up our problem correctly. So instead of units, let's pretend they're shapes, all right? So this example here, so we're starting with a square, right? And we're ending with a triangle. So we have a square on the bottom, on the top, and then the bottom here, a heart on the top, and on the bottom here that cancels, and we're left with the units of triangles. All right, and remember with the train tracks, everything on the top is multiplied and everything on the bottom is divided. Now let's look at this second example. So this example actually has a unit on the top and the bottom, the first one. So our lightning bolts will cancel here, the circles cancel, and we are left with units of, what would that be, moon over whatever that fancy kind of looking square is with the funky corners. I'm just gonna kind of draw it like that, okay? So if we know what units we want in our final answer, we can set up our problem and we'll calculate it correctly. And it doesn't really matter where you put your conversion factors. As long as they cancel, since we're multiplying everything on the top and dividing by the bottom, it will be correct. So let's go ahead and look at how this would work in an example. So how do we get from months to seconds? Okay, so this is time. So let's write out all the conversion factors that we know. Now we'll have to kind of estimate. We know that 1 month equals approximately 4 weeks. It's not exact, but let's say that it's always February, all right? We know that 1 week equals 7 days, all right? We know that 1 day equals 24 hours, all right? We know that 1 hour equals 60 minutes. And lastly, we know that 1 minute equals 60 seconds. So that's where we want to get to, right? So now all we have to do is fill this out with everything on the top and everything on the bottom that would cancel. So we're starting with months. So we're gonna want months down here. We know that 1 month equals 4 weeks. So you might notice that I'm writing this opposite. With conversion factors, it doesn't matter. The ratio is still true, whether it is one way or the other if you do the inverse. We know that 1 week equals 7 days, all right? We know that 1 day is equal to 24 hours. We know that 1 hour is 60 minutes. And then lastly, we know that 1 minute is 60 seconds, okay? So now train tracks, how do we calculate this? If you guys remember, you just multiply everything that's on the top and then divide by the bottom. Well, for this one, we have ones all on the bottom, which is kind of simple. So we will just be multiplying. So we take 4 times 7 times 24 times 60 times 60 again, and we end up getting a really big number. So we end up getting 2.4 times 10 to the, that's going to be the 6th seconds, all right? So there are 2.4 million seconds in 1 month. That's a lot. All right, so let's go ahead and look at another example here. So this example All right, it says that the teachers at BC have been known to assign a good amount of homework. If a student takes 6 core classes a day and each class is assigned 0.5 hours of homework, how many hours of homework is that a student assigned per a marking period? If a school year is 200 days and the marking period is 1/4 of the school year. All right, so we want to know, what do we want to know? Well, we want to know how much homework, so the hours of homework. We want to know the hours of homework. So what we want to know are the hours of homework per a marking period. That's what we want to end up with. Marking period. I'm going to abbreviate a little bit there. So let's go ahead and write down, though there's a lot of information here, let's just write down what we know, all right? So, okay, they give it a lot of homework. They have 6 classes per one day. I know you guys have, all right. And each class, so one class has 0.5 hours of homework. All right, we know that one school year is 200 days. All right, and then lastly, what do we know? Oh, wait, we know that one marking period is 0.25 of the school year, or 1/4. I like decimals better. Okay, so what we want to know are hours of homework per a marking period, right? So let's go ahead and we can start with the hours of homework, right? So we know that each class has 0.5 hours of homework per one class. All right, so let's go ahead and set up, this is going to be our train tracks here. All right, so we've used that one, so I'm going to cancel. I'm actually just going to cross it out so we know that we don't need it anymore. All right, so what else do we know? Well, we know that you have 6 classes per day, right? So 6 classes per one day. We want to put that. So the classes will cancel out here since one is on the top and the other is on the bottom. All right, we know that each school year is 200 days. So we know that there's 200 days per one school year. All right, and then lastly, we know that there's a 0.25 school years per one marking period. All right, so let's go ahead and cancel our units to make sure we're doing this correctly. So we have homework here, classes will cancel, days will cancel, the school year is going to cancel, so we're going to be left with the units of homework per a marking period, which is what we want. So now the only thing left for us to do is calculate. So once again, we're just multiplying. It won't always just be multiplying. Sometimes you will be dividing too, just depending on, right, my calculator is not cooperating. There we go. There. All right. So let's go ahead and start. So we take 0.5 times 6 times 200 times 0.25, and we end up getting 150. That's that's a lot. That sounds like a lot to me. 150 hours per a marking period. That's quite a bit of homework, all right? But that's assuming that you have a half hour of homework for each class, which really, if you think about it, that really would be a lot. That would be 3 hours of homework a night. So hopefully that's not actually true. Hopefully I overestimated there. Okay, so the next problem, I want you guys to try this. So go ahead and pause me for a minute and try this problem, and then I'm gonna go over it with you guys. So pause me now. Let's look at this problem, all right? So we know that we're throwing a party for 15 people, all right? So we know that we have a party that we're throwing for 15 people. And we want to know, like, how much money are we going to spend per party, right? That's what we want to know. So let's go ahead and write this over there. We want to know how much money per a party, right? Okay, So let's look at that. So we know that we're throwing a party for 15 people, and each person or people will eat 4 slices. All right, and you know that one pizza will cost us $14.78. And we also know that one pizza is going to give us 12 pieces, 12 slices. All right, so let's see. So what do we want to know? We want to know how much money will we need for our party. All right, so we're going to start with this. So we have 15 people, right, per a party. And let's go ahead and do this in train tracks. We know that one person is going to eat 4 slices approximately. So we got those 2 taken care of. We know that there's 12 slices per one pizza. All right, and then lastly, we know that one pizza is going to cost us $14.78. All right, so let's go ahead and calculate this. All right, it's a little messy, I'm sorry. Okay, so we take 15 people times 4 slices divided by 12 slices per pizza times $14.78. And it's going to cost us, I did not do that correctly. Hold on. Something happened. All right, so we have 15 people times 4 divided by 12 times $14.78. Oh, here, this is what I'm having an issue with my calculator. I left my good one at school, and we are not there now. Okay, there we go, there we go. Yes, okay, so it's gonna cost us $73, that seems right, and 90 cents. Now that seems appropriate, right? If you're gonna have a party for 15 people, and they're eating 4 slices, and the pizza's not crazy expensive, it's gonna be $73.90 for a party, okay? So that's another thing, is that you kind of want to look at your answer and see if it kind of makes sense depending on like the size of the numbers that you're dealing with, okay? All right, okay, so this is dimensional analysis. If for some reason you set it up differently and it did not work out, you can always go back and redo it, right? So like maybe that I accidentally put the party on the top and people on the bottom, all right? And you end up getting your units with the cost down in the denominator here. You know that's not right. So you just go back and flip it and try it again. So these units are a way of double checking yourself and making sure you do the problem correctly. All right, so I have a couple problems up on my BC for you to try. So it's under the dimensional analysis practice. So go ahead and try those. Just write them down on a piece of paper and bring them into class on Tuesday, and we will go over those. All right, I hope everybody's safe and okay, and I hope you guys have a great weekend, and we will see you